Okay, we're going to do the last three here, which are systems of equations using conic sections. So we're going to solve them algebraically, which means you're going to use one of two methods, either elimination there, right, which is where you get one variable, well, one variable, and you have one of them be like a positive x squared, the other be a negative x squared, so that when you add them together, they eliminate or equal 0. And there's another method called substitution, and this works best. Substitution. There we go. This works best when one of the equations are either y equals or x equals. And we'll get to use both for these three problems. So here you can see this is more like the first with the elimination method because we have two of them that are positive x squared. So I'm just going to multiply, let's say, this top one by -1. Now I want -1 because my goal is for elimination, and this will give me a negative x squared. Now it makes everything else negative, which is fine, right? So I had to multiply this -1 times everything, right? But now when I take the original second equation here, just rewrite it, you'll see if I add these together, this variable x is eliminated. It equals 0. Here I'll be left with 4 minus 1, which is just 3y squared. And 16 minus 4 is 12. Then we can divide both sides by 3. So y squared will equal 4, which means if you take the square root of both sides, y will equal plus or minus 2. We got two answers there. Okay, so there's going to be probably two intersections on the graph. So far, with this information, I know two things, 2 points here. Okay, we know that the y's equal 2, positive 2, and negative 2. Right, now we need to find the x coordinates for each of those y values, and we just do them one by one. So the first one, I'm going to plug into the original equation, right? X squared plus y squared equals 4. And then substitute in one of the y values. So let's do the positive 2 first. So I have 2 squared equals 4. And we'll just solve this. 2 squared is 4, equals 4, and you can see we're running towards equals 0. Subtract 4 on both sides, and square root both sides, so x equals 0. All right. And my guess is that same thing will happen with negative 2, because if you square a negative 2 here, you'll get positive 4 as well, but we can write it out just to prove it. All right, so now we have x squared plus negative 2, right, our other y value, squared, equals 4. So you can see the same thing will happen. We'll have plus 4, because negative 2 times negative 2 is positive 4 as well, and we'll have the same result here. X squared is 0, therefore x equals 0. So it looks like these two graphs will intersect at these 2 points. And I can graph those over here. So we can expect, all right, these two, let's see here, 0, 2, and 0, negative 2. After I graph, they will intersect right there. So let's go ahead and graph it now. Here they are. We have x squared plus y squared equals 4. So we can graph that one first. Right. And we need to know that this is a circle, right? This is a circle. You can tell because they're both squared. Both variables are squared. We're adding, and these coefficients are the same. And it's going to be a circle that has a center of 0, 0, right? We don't have any pluses or minuses with these x's, and the radius is going to equal the square root of 4, right? Which is 2. So basically, we start at 0, 0, we'll go up 2 and down 2, and right 2 and left 2, and you can see already that we are intersecting with our answers that we got earlier. So there's our first graph. Second graph is x squared plus 4y squared equals 16. So x squared plus 4y squared equals 16. Now, these coefficients are different, right? So this is an ellipse, as opposed to here where they're both equal to 1 x squared and 1y squared, so it was a circle. Ellipse is always equal to 1, right? So if it's not equal to 1, we have to divide by whatever number is over here. So if it's 16 over here, we're going to divide everything by 16, because 16 divided by 16 will give us the 1 that we need. But we have to divide everything here by 16. So we're going to have x squared over 16. We're going to have y squared over 4, because 4 over 16 just reduces to 1 over 4. So now we have an ellipse. It looks like we're going to be starting at 0, 0 as well, right? But on the x-axis here, we're going to go 4 to the right and 4 to the left, right? That's where the 16 comes from. So we're going to go 4 this way and 4 this way. But on the y-axis, we have the minor axis here. It's a 4 here, so that means we're going to go up 2 and down 2, right? So that just puts us right on our answers, and now we can see our intersection. So I'll graph my ellipse here. See, it's intersecting right where we calculated algebraically it would. So we got a circle within the ellipse. So two answers are confirmed to be 0, -2 and 0, +2. So it's very important that the two answers you get algebraically are actually the two answers that you get graphically, where they actually intersect when you graph them. So this way you could do the graphing part first, get these two answers, and then when you go do the algebra, you already know that after doing all this work, it should come out to these two answers because that's what we got on the graph. All right, so that's the first one, just two more to go. Right. Here you can see another great candidate for the elimination method because they're already set up to cancel out and equal 0. -4y and +4y already equals 0. So we don't have to do any extra prep work here. So now we have the top here plus the bottom. And it's all equal to 0. So I'm just going to expand this x minus 2, simplify it with this x squared and minus 4, and see what I get. So I need to know that how to expand x minus 2, of course, and I can do this down here. So x minus 2 squared. First of all, it's worth noting that this is not equal to x squared minus 4. It is also not equal to x squared plus 4. It's very tempting to say, I'll just square the x and square the -2, and that will be my answer, but that is not true. It does not work, and I'll show you why. X minus 2 squared means x minus 2 times x minus 2, right? The same thing multiplied by itself. And if we do the expansion here, we'll have x squared, we'll have minus 2x. This is the part that you don't get when you do this. And then underneath here, you'll have another minus 2x. And then finally, you'll have -2 times -2, which is +4. So you get something close to this answer right here. You get an x squared, and you get a +4, but you do not get these two middle terms. So -2 minus 2 is -4x plus 4, which is the correct expansion for this. So we're going to add on x squared minus 4x and then plus 4. That's a 4 here. So let's combine like terms. It looks like we have an x squared and an x squared, right? Those will combine. And we also have a -4 and +4, which will equal 0. So that's good news. Makes it a little bit easier for solving purposes. So the x squared and x squared will make 2x squared. We'll still have this -4x. I'll do that next. But then there's no numbered right at the end because these two actually equal 0 and cancel out. So that's a fully simplified version, and now we can just solve this by factoring. So we'll have still equal to 0, 2x squared minus 4x, just recopying it. Right, these are all zeros. And now I can factor this. They have a GCF here. So both of these have a factor of 2, right? 2 goes into both. And both of them have an x as a factor, right? So I can take out 1x. Right, left over inside, so 2x times what is 2x squared? That's just x. 2x times what is -4? Right, that'd be -2. And those both equal 0. So with the property, the zero property multiplication says if these two multiply and equal 0, that must mean that either one or both equals 0. So I can solve each of these separately and prove my two answers. So I have x equals 0 and then x equals +2. There we go, two answers. So I have so far, like the last problem, I just found out the first part of my answer. So if x equals 0 and x equals 2, I know one of my intersections is going to be 0 comma something, and my other one's going to be 2 comma something. These are both x values, so they're both in the x position. And now I just need to plug each of those back into either of these to get the y values. So let's do that. I'll use, let's see, the bottom equation, doesn't matter which one you use. I'll have 4y equals x, yeah, I'll write it out, x minus 2 squared. And let's check the 0 x's first. So we're going to do 4y equals 0 minus 2 squared. So we'll have 4y is going to be equal to 4, right? And then divide both sides by 4, so y equals 1. So my first intersection will be at 0 comma 1. And then repeat the same process just with an x of 2. So we'll have 4y equals 2 minus 2. Instead of 0 minus 2, now it's 2 minus 2. So that's going to be 0. Squared is 0. So 4 times what is 0? That'd be 0. There we go. So I expect when I graph this, two different graphs, that I'll get one intersection at 0, comma 1. No, yeah, 0, 1, which is right here. And another one at 2, 0, right there. And let's look again at our equations. So the first one we have -4y equals x squared minus 4. So let's write that here. We have -4y equals, I already forgot. Let's see here. X squared minus 4. There we go. And we want to get this in our standard form here, transformation form. So let's go ahead and move this 4 to the other side. That'll give us -4y plus 4 equals x squared. And then we can factor this, and we'll factor out a -4, and that'll give us y minus 1. All right, so this lets me know that the vertex is going to be at 0, comma 1, right? The negative lets me know it's opening down, right? And the 4 is the LOR is 4, which means p-value is 1. Because the p-value is always the LOR divided by 4. All right, so we have all this information. We can start at 0, 1, which is good. That means that's our first intersection point. And if we go down 1 and then right 2 and left 2, right? So I went down 1 because of my p-value equaling 1. I'm going right 2 and left 2 because the whole length is going to be 4. My LR is 4. So this is going to be my first graph here. It's going through both of my answers that I got algebraically. So that's a good sign. And then next, we have one more. We have 4y equals x minus 2 squared. X minus 2 squared. This is already in the correct format. We can already tell here that the center, or sorry, the vertex will be at 0 or 2 comma 0. X is 2, y is 0. And then in the same way, our LR is 4. So our p-value again is 1. Now this one, since this is positive 4, is opening up. So I'm going to start at my vertex, 2 comma 0, just right here. Go up 1 and left 2 and then right 2. So you can see this graph looks something like this. So they intersect exactly where we thought they should, right here at 0, 1 and right here at 2, 0. So that would be completed. Now, there we go. All right, lastly, we have one more system of equations. Let's see here, where to go? There we go. And you can see we have a y equals this time, which means it's going to be better suited for the substitution method rather than elimination method that we did on the first two. So that means that if y equals x plus 1 here, that means this y right here also equals x plus 1. So we can substitute the y in the first equation with, let's see here, an x plus 1. So instead of this y, I'm going to write plus x plus 1 in place of the y, substituting it. And like before, we'll just need to expand these two, simplify, and then solve. So expanding here, we'll have x squared minus 4x plus 4. Remember to expand this, use the same thing we did above right here. X minus 2 squared equals this, right? That's why I have that. And then same thing here, use the same process. When you're expanding x plus 1 squared, you'll get x squared plus 2x plus 1. And that equals 0. All right, and let's go ahead and combine like terms. So we'll have 2x squared, right? We'll have negative 2x, and then we'll have plus 5. So 2x squared minus 2x plus 5 equals 9. And then lastly, we want this equal to 0, so let's actually subtract that 9 on both sides. So we have 2x squared minus 2x now equals negative 4. Minus 4 equals 0. So to solve this, we can do either factoring or quadratic formula, even completing the square. It's up to you. I'm just going to try to factor because I can see that all of these have a factor of 2. So I'm going to take a 2 out, factor a 2 out. There we go. And this is a pretty relatively easy factoring problem where we need to find what multiplies to -2 and adds a -1. So we can easily get, let's see here, probably a 2 and a 1 with the 2 being negative. Yeah, so -2 times 1 gives us -2. -2 plus 1 gives us the -1. So we'll have x minus 2 and x plus 1 as my factors. And this 2 is still here. Doesn't change the answer at all. So my two factors when I solve will be x minus 2 equals 0. So we got x equals 2. And then, of course, x plus 1 equals 0. So we get -1. So we know we have two x coordinates. So 2 comma something, 2 comma y, and then also -1 comma y. So let's find out both of the y values now. And we have a choice here of what equation to use, but hopefully you use the second one here. It looks a lot easier. So it's just y is going to be whatever we got for x plus 1 more. So that's pretty simple, right? So if 1x we got is 2, then the y must be 3. So 2 comma 3 will be one of our intersections. And same thing for the other, we'll have y equals -1 plus 1. So y equals 0. So let's graph our line first. Let's do y equals x plus 1, which is 1 over 1. X has a slope. So we're going to start at +1, right? Up 1 over 1. You can clearly see that I'll go through our two solutions that we plotted. So that will be one right there. Okay. And just a reminder, our two solutions that we got earlier are right here and right here. So if we graph our second equation, which was, let's see here, x minus 2 squared plus y squared is 9, right? This is a center at 2 comma 0 with a radius, right? A radius of 3. Square root of 9 is 3. So starting at 2 comma 0 right here, if you go up 3, left 3, down 3, and right 3, right there is our circle. And looks like our math was correct because they clearly intersect at the two coordinates that we found algebraically. All right, that concludes this review. Remember, you want to be able to do all of these problems by yourself with no help in order to be prepared for the final. Do not just write them down and say you're done with the review because you will not know how to do them for the actual test when you have no help on. Okay, so might take a few times, print out as many as you need and do as many as you have to so you can do all these problems on your own with no help. Good luck.